Hello, I'm Aditi and welcome to my FIP demo video. For any business to be sustainable in long term, it must continually grow and make profits. To make profit, a firm's production cost should be lesser than its revenue. Examples of production costs would be elements like advertising budget, business equipment, raw material cost, and many more. Did you know, according to a survey, procurement teams have identified sourcing of raw materials as the top production cost pressure with 94% importance. Moreover, time constraint has been considered as the biggest challenge in the procurement process, creating an acute need for a more expedited process, achievable by an automated procurement technology-based solution. To accelerate the process of buying resources, raw material price prediction has the potential to gauge the best possible price for any deal in the market, giving firm a competitive edge. Focusing on the problem statement of Company X at present uses a rule-based system for the prediction of raw material. The data that has been provided consists of materials and the prices on a monthly basis. Each material is made from smaller units called feedstocks, and a group of materials form a basket as shown. There are in total 4 baskets of data that has been given to us. The graph shows the prices of the materials and some of its constituent feedstocks. Let's explore the approach used to predict the material price in the exploration. A time series plot is a series of data points where time acts as an independent variable. The main components of a time series can be seen below at one glance. That consists of irregular fluctuations, cyclical component, trend, and seasonality. From calculations, it is concluded that the percentage of missing data of material price was about 70%, while that of feedstock prices is only about 8%. This indicates that feedstock prices will have to be used to facilitate the prediction of material price. The first step is to start with the pre-processing of data. Each price of material and its feedstock is indexed with time. Then, the 2 types of interpolation have been done on data: in-series interpolation and tail interpolation. Cubic interpolation have been done to fill the missing data in the middle of the series. To fill in the tail data, most recent trend and residual values have been combined with the seasonality values. The diagram below shows the impact of the tail interpolation and the in-series interpolation on the time series data. The next step is to perform a correlation study between materials and its constituent feedstocks. The feedstock time series for each material is shifted across different lag values to achieve the maximum cross correlation between material and feedstock as shown. From the correlation study, it can be concluded that feedstock prices individually may not be a strong measure of the material prices. However, each feedstock price, when combined with other related feedstock, has a potential to predict the material prices. The next study performed is the feedstock correlation. There were 3 experiments that were performed. First, the correlation of the feedstock prices with all the other feedstocks. Second, the correlation of the feedstock prices with top 5 correlated feedstocks. Third, the correlation of the feedstock prices with related feedstocks that are causal. These experiments provide an insight into the forecasting ability of a feedstock price using other feedstock prices. Since the high causation need not give a high correlation in the third experiment, all we can conclude is that feedstock time series can be predicted using its causal feedstocks. To create a baseline for the material price prediction, at first, a rule-based model of Company X is evaluated. The MAE and the RMSE of the model turned out to be 5,206 and 25,743, an incredibly large value. And the quality of the prediction can be summarized as follows. Hence, it is clearly evident that this model of estimation of material prices cannot capture significant information from the time series data. Because, as you can see, the thresholds provided, the quality of prediction above 70% is good, indicated by a green color, average, which is above 40%, indicated by a blue color, and bad, which is lesser than 40%, indicated by an orange color. And most of the correlation of the predicted value with the ground truth value is lesser than 40% of accuracy, hence indicated by this pie chart. Hence, therefore, a newer strategy needs to be adopted. From this, we can make three important conclusions. First one being time series analysis for material price is not possible because of high percentage of missing data. Feedstocks can be used to predict the prices of other feedstocks, and related feedstocks of the material can help in the computation of material price prediction. The entire strategy can be summarized using the image below. The metric used to compare the efficacy of each model is accuracy, and thresholds used to make the data representable is as follows. The first step in the strategy is to predict the predict the price of the feedstocks using SARIMA and VAR models. The SARIMA model is trained on its own time series data, and the VAR model is trained on its own time series and related feedstocks, and this can be summarized by the image. The graphs, the pie charts below summarize the quality of the prediction for each model. And as you can see, most of the prediction of the feedstock prices is in the green range. That means it has an accuracy of above 90%. The next step is to finally predict the prices of materials, is to use these prices of predicted feedstocks to use in the prediction of materials. Since the materials cannot be converted into time series data, general ML modeling techniques are used. And the four different possible pipelines are using SARIMA for feedstock price prediction, and then using support vector machine and random forest for material price prediction, or using a VAR model for feedstock prediction and then using support vector machine or random forest for material price prediction. The results of each of these pipelines can be summarized below. And as you can see, once again, the results are in the green zone, most of the results. All the models trained for material price prediction give comparable results and a high inverse MAPE value, or an accuracy value. Almost 85 to 90% of the value is 80% closer to the ground truth price value. Baskets 1, 2, and 4 seem to have a better prediction using the models as compared to basket 3. Nonetheless, even in basket 3, the performance is still above expectations when compared to the overall performance of the model. Hence, this shows that our exploration has been successful. And the graphs below shows an example of the predicted price of material given the ground truth value. Thanks for listening to my presentation.